Okay, this is the worksheet about properties of rhombuses, rectangles, and squares. It's the 7364 practice. So we're supposed to decide whether or not, or what these shapes are. So if we look at number 1, we have both pairs of sides congruent. That's enough for it to be a parallelogram. In number 2, we've got this marked as all sides congruent and right angles. So congruent with right angle means square. It's a rhombus because it's got all congruent sides, and it's a square because it has right angles. If we look at number 3, we have all congruent sides. That makes it a rhombus. So congruent sides is a rhombus. Rhombuses are diamond shapes. The square is a special case of a rhombus that happens to have right angles. Let's look at number 4. Number 4, we've got one pair of sides that are both, so one pair of sides both congruent and parallel. And that's one of the properties that parallelograms have. And then the other thing that we have going on is this one right angle here makes it a rectangle. So rectangle is a parallelogram that has a right angle. Number 5, these are all marked as congruent, so that makes it a rhombus. Okay. Let's look at number 6. We want to find the measures of these numbered angles. So one of the properties of rhombuses is that, let's put it over here. In rhombuses, diagonals are perpendicular bisectors, and also diagonals bisect the vertex angles. And we might have to do like same side interior, alternate interior angles, and also remember the opposite sides are parallel too. So let's see what we have. So for number 6 here, now this is a rhombus, it's a parallelogram. These opposite sides are parallel to each other. So if I do a Z like this, I can see that 54 degrees is an alternate interior angle with angle 2. Angle 1 is congruent to angle 4. Let's see what else we have. Because this is a quadrilateral, all these angles need to add up to 360 degrees. Angle 1 is congruent to angle 4. Okay, also, the diagonals bisect the vertex angles. So this angle is bisected by this diagonal, which means that this angle 3 is also 54 degrees. And same thing up here at the top, 54 degrees. Now together these make 108 times 2, which is 216. If we do 360, take away 216, we get 144. And so these other two remaining angles need to make up 144, plus they're both congruent, so each one of these is going to be 72. Okay, let's look at number 7. This is a 68-degree angle. It's a rhombus. Diagonals bisect the vertex angles. That's got to be a 68-degree angle. Opposite angles are congruent. Or you could do alternate interior angles using the parallel sides, but 2 and 3 are both also going to be 68 degrees. Now, altogether, these two 68s add up to 136, and we've got another 136 down here at the bottom. Altogether, these inside angles need to add up to 360, so see what we have so far. And then we're going to have to do a divide by 2 because these two angles are congruent to each other. And then take it half to get angle 1. So this adds up to 12, carry the 1, 6, 7, 272. So if we do 360 minus 272, we get 88. So these two angles make up 88 degrees. Each one of these must be 44. And that means that this half has to be 22, and this half has to be 22. So we found those. Okay, let's look at number 8. Switch colors. See what we got. Okay, so rhombus again. Angle bisects. There's a 20 there. Also on this side, we got a 20 and a 20. Okay, let's look at the other side of the sheet. Stop. Okay, so for number 18, they are telling us that HIJK is still a rectangle. We want to find the length of X. I'm going to draw a new rectangle on this page. So I'll draw it over here. Then it's still HIJK. And let's see what we got. So H to J is 4X, and I to K is 7X minus 12. Again, we have a rectangle which has congruent diagonals. They're giving us algebra that describes the diagonals. They have to be congruent. We set these equal to each other. So 4X equals 7X minus 12. Take 7X away from both sides. Minus 3X equals minus 12. X is going to be 4. And if X equals 4, we plug it in, we get 16 for the length of the diagonal. So X is equal to 4, and then 16 is the length. Over here, HJ again, and IK, same thing. These two diagonals are congruent to each other. So X plus 40 equals 5X. Take X away from both sides. 40 equals 4X. Divide by 4, X is equal to 10. Now if X is equal to 10, the length of the diagonal is going to be 10 plus 40, which is 50. So we have 50 for the length of the diagonal, and 10 is equal to X. Let's find the precise names for these quadrilaterals. So we have opposite sides parallel, or opposite sides congruent. That's a parallelogram. So at 21, we have all sides congruent. That makes it a rhombus. And we also have right angles. So we have a rhombus with all right angles. That is a square. So at 22, we have opposite sides congruent with a right angle. That makes this a rectangle. It's a parallelogram because of the opposite sides congruent. It's a rectangle because of that right angle. And number 23, all sides are congruent. It's a diamond shape. We call it a rhombus. Or HOMBUS. Second 24, we want to find the values of the variables, then find the side lengths. Let's see what we have. Let's change colors up here. So opposite, this is a square. So square means all sides are congruent. So these two are going to be equal to each other. So we could say that we need to say that 3x over 5 equals x minus 8. Now to get rid of this denominator, multiply everything by 5. 5 times this side, basically cross cancels out the 5. But we also have to do 5 from this side over here. So we end up with 3x's is equal to 5x minus 40. Take away 5x both sides, minus 2x's. is minus 40. By my minus 2, x equals 20. So x is equal to 20. That means that each one of these side lengths is 12. So we're over here at this next rhombus. They're telling us it's a rhombus. Opposite sides on a rhombus are congruent. So m plus 12 must equal 3m. Take m away from both sides. 12 equals 2m. Divide by 2, m equals 6. Now if m is equal to 6, each one of these sides is going to be 18, because it's going to be 6 plus 12, or 3 times 6. For number 26, it tells us we have a rectangle. That means right angle, opposite sides parallel, and opposite sides congruent to each other. So x is equal to 4y, and 3x minus 10 is equal to 2y. So what can we do with that? I could, since x is equal to 4y, I could, every place that there's a y, well, here we have a 2y, so we need a 2y there. 1/2 x is going to be 2y. So every place there's a 1/2 x is equal to 2y. So what I could do is replace this 2y with 1/2 x. So I use the first equation they give us. These two have to be equal. X is equal to 4y. Cut it in half. 1/2 x is equal to 2y. Now since 2y is equal to 1/2 x, I can substitute 1/2 x in there for that 2y. Now I can do these opposite sides congruent and figure out what x is. So since they're congruent, I can set them equal to each other. 3x minus 10 is equal to 1/2 x. Double everything to get rid of the 1/2. 6x minus 20 is equal to 1x. And take 6x's away from both sides. Minus 20 is equal to minus 5x. Divide by negative 5, x is equal to 4. And so if x is equal to 4, we got 4 for that side. We got 12 take away 10, which is 2 for this side. We got half of 4, which is 2 for this side. And it must be that y is equal to 1, because this side also has to be 4. 4 times 1 equals 4, so y equals 1. And we found those. Found out that x is equal to 4 and y is equal to 1. Let's look at the next one over here. We got a square. So all sides in the square are congruent. So these two can be set equal to each other. X plus 7 has to equal 3x plus 1. Take away x from both sides, 2 x's, and then take away 1 from both sides is equal to 6. Divide by 2, x is equal to 3. So if x is equal to 3, that side's a 10. 3 times 3 is 9, plus 1 gives you 10. So those side lengths are 10. And we won't really bother doing this paragraph proof, but let's just go ahead and draw the diagram and see what we can see from it. So we've got a rectangle, and they're calling it DVEO. And diagonals are DE and OV. Prove that OVE, O to V to E, this triangle, is congruent to this D, OVE. So that OVE is congruent to DEV. It wants to show that these two triangles are congruent. So let's see what we can do by way of argument here. Well, if we kind of look at this one triangle, the DEV one, well, which one did I do? I did this one. So this is the OEV triangle. And then the other triangle that we're dealing with is this one here, which is the DVE triangle. Well, DEV, D to E to V. And then this one was O to V to E. So they want to show these two triangles are congruent. Well, really what we have is these opposite sides are congruent. So in the proof, we could bring out that those two sides are congruent to each other. Where'd my drawing go? So what that does is gives us actually this side and this side is going to be congruent because opposite sides in a rectangle are congruent to each other. These angles at V and U are going to be right angles. Well, at V and E are going to be right angles. And then the other side here is congruent between the two. They're both sharing the same side. This VE side. So VE is shared. That gives us side angle side as a pattern we can use. Or it also gives us hypotenuse legs, since these are right triangles, and you got a, and the diagonals are congruent. So if the diagonals are congruent also, that gives us the hypotenuse part, and then the legs are the two sides being congruent. So with right angles, you could use hypotenuse leg. With just in general, pattern-wise, you can use side angle side. So that would be what would have to come out in this proof.